Hello guys. So today we are going to discuss something that is a very important concept of JavaScript. It actually forms the basis of whatever JavaScript runs under the hood. You will be able to truly grasp how JavaScript actually handles asynchronous code, like handling promises, handling callbacks, doing network calls, IO operations, right? Using stuff like set timeout and set intermediate, all those asynchronous concepts that you might have worked with in JavaScript. So this will actually paint a very clear picture on your understanding of JavaScript, and it will actually make you a better developer as well, because now you will be able to visualize how JavaScript is actually running under the hood, and it will actually make you write better code also. So if you are a senior developer, or you are someone who is working with JavaScript and who is working in JavaScript frameworks, from the interview perspective also, this is a very important concept, and based on my experience itself, it's a very popular question related to event loops, right? They can basically ask you to describe how the event loop works actually, or they can actually pick some particular component of it, and you need to explain that. So event loop is something that actually enables JavaScript to run asynchronous code in a synchronous way. What do I mean by that, right? So let's start with some basics here. So JavaScript, by definition, if you're already aware, that it's a single-threaded programming language. So whatever JavaScript does, it has to be synchronous in nature, right? So one instruction after another. So if you're aware of threads or worked with threads a bit, so in a thread, so whatever instructions are in a thread, so the thread always takes one instruction at a time and it executes them. So JavaScript, since it has a single thread, it only has a single thread, it can only execute instructions in a sequential manner. There is no concept of concurrency here. For other programming languages, if you have worked with like C++ or Python or Java, so they have the concept of multi-threading there. So you can actually create multiple threads, and you can have different tasks that are assigned to each thread, and you can work with it. But in JavaScript, it's a single thread. And somehow it is able to do all this stuff, like all this, it can actually make an API call or do some IO operations in a non-blocking manner. So this non-blocking is a very important point here. So if it were a blocking problem, so let's consider an example here. So if JavaScript was blocking in nature, we have this fetch function, right? You are hitting some API, and let's say it is taking 5 seconds, right? And let's say your browser is doing that. You are on your browser and google.com is hitting some server that is taking 5 seconds. Now, if JavaScript was blocking in nature, what would happen? So unless and until it completes that 5-second time, time duration, it won't be able to actually do anything else other than this in that time. So let's say it has some API that is fetching the google.com image, right, from some S3 bucket. So until and unless it completes finishing that, you won't actually be able to type anything in the search bar, and that is a very huge problem. That actually is a very bad experience for the user. So if you have hundreds of functions of this kind, your entire call stack will get blocked, because all those functions will pile up and you can't. So the browser will freeze at that moment, right? So it is very important for JavaScript to be non-blocking in nature. So it should be able to handle asynchronous code in a non-blocking manner. What do I mean by that? Is that let's say it is making some API call, and now the API call can take some time, let's say from 5 milliseconds to 5 seconds, right? It can vary. So in that point of time, so JavaScript shouldn't actually care about that. It should just let it happen, and meanwhile, while it is executing that, it should be able to pick up other tasks that are already lined up and then execute them. So this is how non-blocking code works. That if some task that is taking a long time, like a long running process, you shouldn't wait for it to complete. So you can think of it like let's say you are in a coffee shop and you are placing some order. So it's not that when you go to the counter and you give an order, it will immediately give you that coffee drink. The coffee shop is actually preparing your order, and after some time it will give you your coffee. But while it is making your coffee, it's not like that it is not taking somebody else's order also, right? So somebody who is standing behind you, he will immediately come after you have placed your order. And process of making your coffee doesn't actually affect taking other orders also, because right, because then the coffee shop won't work. So this is how asynchronous programming also works. So this is actually your event loop. So I have created this diagram, so I hope that it helps you understand it better. So this is your call stack, right? So this is where all your functions come one by one for execution. So we have a fetch function, a console statement, a set timeout, and again a control statement. I'm just taking a simple example here. So what does this fetch actually do? So fetch is calling an API, right? And let's say this fetch is taking 5 seconds. Now, if it were non-blocking, as I said, this should just sit here and all these functions below will choke, right? But JavaScript, so JavaScript should actually take care of that. So how it does it is, we have something called a web API. So these APIs are actually the way how JavaScript executes asynchronous code. So for simplicity, let's just take this set timeout example. Forget about this fetch for now. Let's take this set timeout example. So set timeout, what it does is it will print this console statement after this is 5000 milliseconds. After 5 seconds, it will print this console statement. Now, JavaScript will know that this is actually an asynchronous piece of code. So it is already aware of that, right? By syntax, it can see. So what it will do it will basically send it to this. So as soon as JavaScript sees some asynchronous code, it will send this to a web API handler, right? Now this is very important to understand. So this is your web API handler. Call stack sees this set timeout statement, and it will say that you go there, you go to the web API handler, and he will take care of it, right? So now this web API handler is actually responsible for putting whatever function you need to execute after 5000 seconds back into this call stack. I'll just quickly show an example to make it clear. So for browser, you have something like this DOM events, like in browser you can actually perform DOM events like click or drag or something, right? So these are all callbacks. So once you click, there is some callback that is generated and that is executed in your JavaScript. But Node.js doesn't have this DOM, this click kind of functionality, right? So all these asynchronous concepts are actually handled out of the box. So these are not actually part of the JavaScript engine, except this promise.then and this async await. Or there can be some common stuff here that are actually part of the JavaScript engine, but most of them are handled by the web APIs only, right? So this set timeout will actually be dependent on your environment, how it is handling. So this is your browser environment. So this browser, so the web APIs will see that, okay, this is something that needs to be executed after 5000 seconds. Now one thing to note is that this web APIs, however it is handled, it is not the responsibility of JavaScript to see that how it is actually executing. So it can be a separate thread itself, it can be a separate process. So after 5 seconds, what this web API will do, it will just push this code, right? This console.log statement, which is a callback, and it will push it to this callback queue, right? So whatever asynchronous code is present, it will first go to this web API's handler. The web API's handler will see how to execute this particular function. Once that execution is done, let's say 5 seconds has elapsed, it will push the callback, the actual code that needs to be run, which can be a synchronous or an asynchronous code, and it will put it I'll just make a copy of this and just put it in this callback queue. Right, I'll just keep it here for now. So you can see that there are two other queues here also. One is a micro task and macro task. I will come to that later. But first, so just consider, just forget about these two. We just consider one queue here, which is the callback queue. So after this web API handler executes, it will push this statement, will push this instruction into the callback queue. Now what this callback queue will do is that it will wait for this call stack to get empty. Right, so it will actually go one by one through all the synchronous and asynchronous code, and once all this or whatever functions there is present is executed, it will then push an element out from this callback queue into the call stack. Right, and then only it will execute this piece of code. Understood? So to repeat, first the call stack will see that it is an asynchronous function. It will send that to the web APIs. The web APIs will see how to handle that particular request, right? And after that operation is finished, it will push it to the callback queue, and then the callback queue will see. So this is all handled by an event loop or an event manager. So there is a event loop here, let's say, right? So event loop actually handles all this orchestration logic. So event loop takes care of whatever is there in the call stack, what's the status of this callback queue and everything, right? So event loop, what it will do, it will just see that this call stack is empty or not. Once this call stack is empty, after that only it will push a task or multiple tasks from this callback queue to this call stack. And then again, if it is again a asynchronous process, then again this loop repeats itself. Right? Understood? So this is how actually your JavaScript runs in a non-blocking manner. So whenever it encounters an asynchronous function, it will send that to the web API handler. It will handle on its own depending on the environment it is in. Then it will push it to the callback queue, and from the callback queue again it will come to this call stack, right? So then in the call stack, if it is synchronous, it is executed immediately. If it is again a asynchronous process, like a callback within a callback, then again it will go to this web API's handler, then again it will come to the call, and this cycle repeats. So as we can see here, this is actually your chain of action that is happening. So first it will execute the script. So execute script means that it will execute everything that is in the call stack currently. So let's say you have a file and you have 100 lines of code there. So it will first execute everything in your that file, be it synchronous or asynchronous. Whatever is asynchronous is sent to this web APIs for processing. But it will first finish all the synchronous and asynchronous code. After that, what it will do is it will run a macro task. So this callback queue is actually divided into two. It is further divided into two queues. One is your micro task and one is your macro task. So macro task is something that is you can call it like a major task, right? And event loop only picks one major task and puts it into the call stack, right? So in a single loop, it will only pick one macro task and it will put it in the call stack. Then after that, it will look at this micro task queue. In the micro tasks are small tasks. So for example, I'll show you again in the table that I had. So micro tasks are basically small tasks, let's say then callback or finally callback. So all these are micro tasks. So these are simple tasks that can be many in nature. Usually it is like there can be a lot of micro tasks as one at once. So all these micro tasks will be so whatever is there in the micro task, all will be sent to this callback queue. To reiterate, so one task from the macro task and all tasks that are currently present in the micro task will go to this call stack for execution. Then this re-render UI, this is very browser specific. This is not central to Node.js. It's only for browsers. Then for Node.js, this is this arrow should be from here till here. But basically, this cycle will again repeat. So again, it will look at the script. Again, it will go to the micro script. Basically means that this checking the call stack basically, and then again it will run a macro task. Then all the micro tasks. Then again, this cycle repeats. So let's now see like what kind of things are micro tasks and micro tasks in JavaScript. So I have created this table for your reference. So I have divided this into browser and Node.js. So let's set timeout. This is a macro task. Your fetch, the initial fetch is a macro task, but all the dot then operations, those are part of your micro task. So once your URL is executed, the dot then will act as a micro task and will be put in this micro task queue. So similarly, for Node.js, we have this file system operations. Those are micro tasks. Set timeout is a macro task again. Promise dot then is a micro task, right? Async await is a micro task. So this is how JavaScript actually decides like in what queue to basically put this particular request in. Now you will notice one thing, that this set timeout, I'll just take one example. So this set timeout is actually a macro task, right? So what is set timeout? Set timeout is used for executing some function after a specified period of time. So now you see is that since set timeout is a macro task, so for macro task it's always one task at a time, right? So only one task will be picked from here and put into this call stack. Now since set timeout is a macro task, so only one set timeout function can go from this callback queue to this call stack. Now the problem is that let's say you have a long list of micro task queues, micro tasks in this micro task queue. Now since set timeout is actually you have specified that it should run after 5 seconds, it might happen due to some delays here. This can actually take a time that is much longer than 5 seconds. Much longer means, I mean, it entirely depends on the context, but you can see that this set timeout functionality is not actually accurate in nature because it is highly dependent on the performance of this micro task queue. Unless and until all these micro tasks are run, let's say it only takes one set timeout at a time. So if I have like two set timeout functions, both for like 1 second interval, then what will happen, that first will execute fine because first we are executing this macro task only. I think no, because this macro task also, it will only execute after all these micro tasks are also put into this call stack. So the first execution also would depend on the performance of all these micro tasks. So this is where the inefficiency arises, and so this is one of the pitfalls that usually happens in JavaScript, and this is a very common question that comes up in interviews, whether this set timeout is actually accurate in nature. The answer is no, because it is highly dependent on this micro task queue. So that is all for event loops. I hope this video was helpful to clear your doubts, whatever you had, and yep, see you in the next one.